We are moving into our almost last chapter. We do a tiny little bit of chapter 6 after this, but for the most part, this is our last big chapter. We are going to be studying conic sections, and conics are sections of a cone, okay? We are going to focus on parabolas for about 3 days, and then we'll look at ellipses and hyperbolas. The circle is also considered a conic section, but we covered that beginning of the year, so we're not going to go back and revisit that, okay? Do you guys remember the equation for a circle? Okay. Yeah. Okay. So we are going to be looking at parabolas today, and we'll see something similar to that equation for a circle when we start getting into ellipses and things like that. Okay. And you guys have read through this page? Questions on anything? Just some background information. All right, so like I said, our focus today is to understand how conic sections are formed, understand the geometry of parabolas and their key features, and we're going to start writing equations and graphing parabolas. Then the next day we'll start looking at how do we translate them, and on day 3, how do we do some applications. Where would you see parabola equations in real life? Okay. Conic sections. If you took an axis, okay, just a nice vertical line, and then you had a second line that was diagonal to that, if you spin it, that diagonal line, when you start spinning it, creates the cone. Okay? And it's called a double cone. You've got 2 cones upside down on each other. All right? It says, imagine 2 non-perpendicular lines intersecting at point V. If we fix one of the lines as an axis and rotate the other one, called the generator, around the axis, it sweeps out a right circular cone. All right. So conic sections, or conic for short, is just a cross section of a cone. It is the intersection of a plane with a right circular cone. And our 3 basic conic sections that we're going to be studying are the parabola, ellipse, and hyperbola. All right, so on the next page, you will see, we're still writing? Okay, this is where our shapes come from, all right? If we take a double cone and we slice it parallel to the base, okay? This isn't one of our pictures up there. Parallel to the base, we would get this shape, just a circle, okay? If we slice it not parallel to the base, we get an ellipse, okay, an oval shape. That's the first picture you see there. If we slice it perpendicular to the base, come on, we get a parabola, okay? And if we do that and we have 2 cones, one on top of each other, we get the 2 branches. That becomes our hyperbola. Does that make sense? Okay. So that's why they're called conic sections. They're just cross sections of a cone, slicing it different ways. If we were to slice it through where the 2 points of the cone meet, we would just get a single point. Okay? If we slice it parallel and right along the edge of the cone, we just get a line. Okay? And then if we slice it right through the center perpendicular to the base, we're just going to see 2 intersecting lines. Okay? But our focus as we go through this chapter, just the top 3 pictures, the ellipse, hyperbola, and parabola. We're going to start with the parabola today. All right, it says the conic sections can be defined algebraically as the graphs of second-degree quadratic equations in two variables, where a, b, and c are not all 0. It looks like this. So we have some x squareds, we have some xy combined terms, we have some y squareds, we have plain x's, plain y's, and a constant. Now, not all equations will have all of those pieces, but as long as a, b, and c are not all 0, you're going to get a conic section. Okay? And to convert from this format into one of ours that we can recognize what shape it is, we would have to complete the square. Okay? We won't get to that today. All right, so some specifics about the parabola. And I do want to emphasize, and I'll probably be saying this every day as we go through this chapter, do not wait until you're studying for the test to memorize your formulas. We're going to start out each day with a shape and having it kind of centered or vertex at the origin, all right, the easy ones. And then we're going to look at what happens when we translate away from the origin. Okay? So you're going to have a basic equation, you're going to have a translated equation. If you memorize just the translated one, that's fine. Because if it's centered, or for a parabola, if it has a vertex at the origin, you just have 0, 0 as your coordinates, right? But you're going to have formulas or equations that we use for ellipses, hyperbolas, and parabolas. And they all have some things that look similar, but the differences are critical. Okay? So as you go through each different shape, make sure you know what are the key things I have to know in order to get that shape graphed or in order to write an equation for that. Okay? For example, with a circle, if we know where its center is and how big the radius is, we can write an equation. Okay? Those are the key features of a circle. What is its center? What is its radius? But each shape is going to have its own key features. You need to know how to figure those out. Okay? So again, please make sure as you're going through this chapter that you put some time in each day to review that material so it's not all you're trying to memorize it at the very end. All right, so definition of a parabola. It's the set of all points in a plane that are equidistant from a particular line called the directrix and a particular point called the focus. So in a parabola, directrix and focus are some key features that you need to recognize. The line passing through the focus and perpendicular to the directrix is called the focal axis. We often referred to it as our line of symmetry when you were first studying parabolas a few years ago. Okay, so in our picture, this is our focal axis, right, or our line of symmetry. The point where the parabola intersects its axis is the vertex. Uncover that. Vertex of our parabola. Okay. It says the vertex is located midway between the focus and the directrix and is the point of the parabola that is closest to both of those things. So looking at our picture down here, if we have a vertex right here, focus is here, directrix is a line on the opposite side. It says the vertex is midway between those two things, which means this length and this length are the same. Okay? It says the distance from every point on the parabola to both the focus and the directrix is also the same. So it doesn't work just for the vertex. Any point on my parabola, if I draw a line perpendicular to the directrix from that point, okay, so looking at this one here, I go perpendicular to my directrix and I also connect the point to the focus. These are the same length. Okay? That's what creates your parabola. For any point on there, You go perpendicular to the directrix and to the focus, connect those 2 points. It's always the same length. Okay? All right, so standard form. It's going to look a little different than what you're used to. We are used to writing things like y equals ax squared plus bx plus c, right? That's a basic quadratic equation, and if we graphed it, it would be a parabola. We aren't going to use that version of it. We could do some completing the square that would turn it into the one we're going to use, okay? So the ones I need you guys to start memorizing are in the little orange boxes here. We have an x squared equals 4py, and down below we have a y squared equals 4px. So highlight those. So when I say, what is my basic equation for a parabola, you're going to give me those two. Some things to notice about them. One of them has an x squared, the other has a y squared. But both variables aren't squared at the same time. The other shapes, like the circle, the ellipse, the hyperbola, all have x and y's both being squared. So that's one of the ways you can make the distinction that this is a parabola, because it only has one of the variables being squared. Okay? Now, you've spent a fair amount of time with these top two pictures, graphing parabolas that open up or down, right? What made it open up? When the term in front of the coefficient of x squared was positive. So the same thing in my version of it. If p here is positive, it opens up. Okay? If p is negative, it opens down. Okay? Looking at the ones underneath here. This time, the y is being squared, and the parabola is open to the side, left and right. Okay? Again, hopefully it's logical. It's going to open to the right when p is positive. It's going to open to the left if p is negative. Okay? Now, in all of the pictures, they have labeled the focus and the directrix. Notice that the focus is always inside the curve of the parabola, okay, on the line of symmetry or on that focal axis. The directrix is going to be a line perpendicular to the focal axis, but a line that your graph is curving away from. Okay? Your parabola is never going to intersect with the directrix. It's on the opposite side. So if your parabola is opening up, your directrix is going to be down below it. If your parabola is opening down, your directrix is going to be above it. Okay? It always is going to curve away from the directrix and around the focus. And we said that the distance from vertex to focus and vertex to directrix are the same length. So if we go, for example, p units above the vertex, our directrix would be p units below it. Okay? So whatever my value for p here is, my directrix is going to have the opposite coordinate. Yes. Her question, is there only one specific directrix and focus for every parabola? Yes. They're all unique. And you can tell what it is based on the equation. We're going to get to that in a minute. If our focus has been moved down from the directrix or from the vertex, all right, we had to go in a negative direction, then this p-value here is negative, and the directrix is going to be actually a positive value. It's the opposite of p. Students often look at that label and say, well, that doesn't make sense. Why is p, or why does y equal negative p up here when it's in a positive part of my graph? All right, it's not saying it's a negative number. It's saying it's the opposite of what p was. Okay, so if we're down here, say at the point 0, -5, our directrix is going to be the line y equals 5. We okay with that? All right. Same thing with the side-to-side ones, okay? Your focus is inside your curve. Your directrix now would be a vertical line on the other side of it, and it would have an equation x equals something, okay? And it's always going to be x being the opposite of whatever p was. Okay, for today, our vertex is always going to be at the origin. Tomorrow or Monday for you, we will start shifting that vertex away from the origin. So it's really critical when you look at the initial information about the shape that you know, what does that P stand for? All right. Right now, we're basing it going from the origin. But again, we can shift that vertex point. We can still measure P units from it. All right. It's just going to be at a different location. All right. A couple terms that you need to know. The focal length is the value of P in our equation. Okay, that's called the focal length. It is the directed distance. You might want to underline. Directed distance going from vertex to focus. It's directed because you have to know, am I moving in a positive direction? Am I moving in a negative direction? Okay. Is P a positive value? Is it a negative value? So it's always being measured from vertex to that focus point. Whether it's moving up, right, left, down, it's still a directed distance. A chord is a line segment that connects two endpoint that has its endpoints on the parabola. That term should sound familiar from geometry, right? Chords of circles. All right, and then the last term, the focal width, is defined to be the absolute value of 4 times P. So the focal width is not directed, all right? It doesn't, we don't care whether it went positive, negative. It's a positive answer. It's the absolute value of whatever 4P is. And remember that in our equation, we had x squared equals 4py or y squared equals 4px. Okay, that 4p, that number that you're going to see here, is going to be your focal width if you ignore any signs. Okay? The focal width is the length of a chord that goes through the focus and has endpoints on the parabola. So that's going to give us a way to get 2 other points beside our vertex so we know how wide is this parabola supposed to look. Right? The information in our chart here is just a summary of everything that we've had in the pictures. My recommendation is not so much to memorize each of these things in this chart, each column, but to think in terms of visualizing a picture of it. Is this a parabola that's opening up? Is this a parabola that's opening to the side? All right. From that picture, you should be able to tell, well, what would the directrix look like? Is it an x equals a number, or is it y equals a number? Horizontal, vertical lines, what is it? And you can tell based on which way the parabola opens. Okay? All right, so let's start with example 1 here. It says, find the focus, the directrix, and the focal width of the parabola, y equals negative 1/3 x squared. My hint to you is put it in standard form first. In our standard form equations for parabolas, we said x squared equals 4py or y squared equals 4px. You have to get the squared variable alone. So in my example here, if y equals negative 1/3 x squared, what do we have to do to get the x squared by itself? Dividing by negative 1/3 or multiplying by negative 3. So we get negative 3y equals x squared. We good with that? Okay, now compare it. In my generic formula, x squared equals 4py. So the 4p and the negative 3 are really the same thing. Yes? The number that you see in front of the y is taking the place of 4p. All right, so let's write an equation for that. The negative 3 is taking the place of 4p. So what is p? Okay. And once you know that, and you've identified is it the x squared or the y squared kind, you can find everything. All right, so let's visualize it. Like I said, picturing it's going to make this so much easier. So the things I would analyze, it's x squared equaling 4py, right? We had x squared equals negative 3y. So is it going to open like the up and down kind or the left and right kind? X squared are the ones you've had a lot of practice with, right? Those are the up and down ones? Okay, so based on this, we know it's going to be up or down. And since p is a negative number, it's going to open down. Okay? So we're going to picture a parabola. We said today the vertex is going to be at the origin. And we know it opens down. Okay? From that information, I know that my focus is going to be somewhere on the negative y-axis. Yes? Because it's inside the curve of the parabola. So I know that I'm going to have a focus somewhere over here. Okay? And then I know that my directrix has to be a horizontal line on the other side. Same distance, but going outside of the parabola. Okay? And we said that P was the directed distance from the vertex to the focus. So that tells me that I am going negative 3/4 of a unit from my vertex. So what are the coordinates of this point here if I had to go down 3/4 of a unit to get there? Yeah. So when they ask you for your focus, you would say 0, negative 3/4. Now, if the focus is at 0, negative 3/4, where would the directrix be? At positive 3/4. So what would the equation be for this horizontal line up here? Horizontal lines are always what? Y equals, in this case, 3/4. So my directrix is y equals 3/4. Okay. The last thing they asked us to find is the focal width. The focal width is defined as the absolute value of 4p Well, in my equation, 4p was negative 3. Yes? So if I take away the negative sign, my focal width is 3. Okay? Now, what that means is if I made a chord going through the focus with endpoints on the parabola, that would be 3 units long. Okay? So if I were to graph this, if I know where the focus is, could I split that and say, well, if the whole thing has to be 3, then I would go 1.5 spaces on each side? And then I'd have a couple points to help me get my shape for my parabola. Okay? All right, let's try the next one. Find an equation in standard form for the parabola whose directrix is the line x equals 2 and whose focus is the point negative 2, 0. Again, draw a picture. It can be a rough one. It doesn't have to be perfect, but it's really going to help you figure out what it is we're trying to do. So the line x equals 2 is over here. So that's my directrix. We said the vertex today was going to be at the origin. And the focus is at the point negative 2, 0. So from that information, which way is this going to open? has to open to the left, right? It has to curve around the focus and away from the directrix. So we know that my parabola is going to have to curve this way. Yes? And so if it's curving to the side, opening to the side, is it the x squared or y squared kind? Okay, so we have figured out that we need the y squared kind. We know that it has to open to the left, right? What is the directed distance from vertex to focus? How many spaces did we go and in what direction? Positive or negative? We went 2 in a negative direction, right? From vertex we went to the left. Okay, so we know that P has to be a negative 2. That's the directed distance from vertex to focus. So if we know that if we want the y squared kind and that P is negative 2, we've got our equation. Y squared equals 4px. So plug in a negative 2, and what do we get? Y squared equals negative 8x. That would be my equation. We okay with that? All right. Next example, it says find the focus, directrix, and focal width of this parabola. I'm going to pause the video for just a sec. I want you guys to talk at your tables. Is this opening left or right, up or down? What is my value for P based on my equation? Looking at our equation, y squared equals 12x. So it's y squared, which tells you what? It's going to be which way? Sideways ones or up and down ones? Okay, so it's going to open to the side. And we compare it to our generic one, y squared equals 4px. So the 4p and the 12 are the same, right? So that means p has to be 3. Okay, so we know it's going to open to the right because p is positive. Okay. All right, so let's sketch what we know so far. We've got a vertex at the origin. We know it's going to curve to and open to the right, and our directed distance from the vertex to the focus is a positive 3. So we're going to go 3 units to the right to get our focus. Okay. So what are the coordinates of our focus? 3, 0. Okay. Then it asks for the directrix. Well, if the focus is 3 to the right, the directrix is going to be 3 to the left. Okay, so we're going to have a directrix line over here. What would the equation for that directrix be? Good. All right. So we've answered the focus, the directrix, then the focal width. Focal width is the absolute value of 4p. Well, what was 4p in my equation? A 12. Absolute value of 12 is 12. Okay. Now, it says to sketch a graph of it. If you know the focal width is 12, then the chord that we draw through the focus has to be 12 units long. Okay? And it's symmetric, so you're going to have half on each side. So I'm going to go 6 spaces above the focus, and I'm going to go 6 spaces below the focus. And now I have a couple points that I can aim at to draw my parabola. And that gives me a good idea of how wide the parabola should be. Okay? So remember that this space here is half of your focal width. Okay? Or 2p. Questions? So, can you sketch a picture of a parabola based on information? Can you write an equation for a parabola given information? Okay. So, our next topic will be we start shifting these off of having the vertex at the origin. let's see, your assignment is there.